Why don't they listen? Why don't people listen? Listen. We're talking about listening. Why don't people listen? Give me 5 reasons why people don't listen. Yes.
Short attention span.
That's too technical. Short attention span. Too specific. ADD. They don't want to. Excellent. It's a choice. They choose not to listen. That's very good. What else?
They're not interested.
Lack of interest. Oh, I like that a lot. I like that a lot. What else? What's a big one? Ooh, that's big. They're tired. Or distraction. That's excellent. What else? Go ahead.
So they think that talking is more important, so they start talking instead of listening.
So it's a question. All right. So they think talking or talking on a cell phone or texting, or they think something else is more important. So it's a question of priorities, maybe. Okay. Yes. Yeah, we said bored as opposed to listening. Nope, I gotcha. Okay.
She wasn't listening.
Yes, thank you. I think I made that point. But it's always nice to hear things twice. Right. So, and it's one of the reasons people say that I'm a good listener. Sometimes I'm a terrible listener because sometimes I'm really tired and I just want people to go away. You ever have a day like that where just get out of my face, just go away? Red, I don't want to hear your problems today. I really don't care. Okay, go away. But, I've got to do it every day. I've got to listen to students and I've got to hear what they're saying and I've got to respond. And it's hard. By the end of the day, I want to be alone. I don't want to do anything. I want to be alone. Yeah. I just want to be a potato. I just want to, go for a walk alone. I want to be alone. When I go home and I was raising 3 daughters, I just want to, it's like finally turn the light out. It's the only time you had it quiet. It was like the lights out. Wow. So I always like when the kids were in bed before I go to bed, those golden years, when they're actually in bed. My wife and I would say, we would just sit there and we wouldn't even talk. We'd just sit there and say nothing. It was wonderful. Okay, so here I have the test in front of me. Shall I read you a couple of problems just to give you maybe some reduce some anxiety? Okay. All right. Here we go. You ready?
Yeah.
You ready? All right. I'm not going to tell you what number it is, nor am I going to give you the choices. Okay? All right. Nor am I going to entertain a discussion. I'm just going to read the question. Clear? Okay. You ready? I don't care what you do with it, but I'm not repeating it. Okay, you ready? How do the isotopes hydrogen-1 and hydrogen-2 differ? Okay. Let's do another one. One more? Okay. Here's one. You ready? This is a good one. What is the relative mass of an electron? I don't want to discuss it. Didn't I say that, or you weren't listening? Gotcha. Okay. One more. All right, you ready? This is really good. I like the choices. Who was the man who lived from 460 BC to 370 BC and was among the first to suggest the idea of atoms? Okay, so that's just 3 quickies. Okay, now let's review. What you need to know. What do you need to study? Well, first of all, I had a discussion with someone and they said there's too much information in the chapter. I don't think so. Now, I'm not going to turn the camera around, but I'll do an honest, objective analysis of the answer to my question. How many people feel that in terms of what you've had before and in terms of how easy this is or hard, how many people find this relatively straightforward? Raise your hand. Okay. How many people, shall I answer that again, ask that again, and this time, instead of thinking, actually raise your hand if you feel that's true? Or should I rephrase the question? Only about 3 people raised their hand. Okay, all right, so let me rephrase the question. How many people feel that there's just simply too much information in a chapter, and it is in some ways quite beyond your capacity to learn this in 3 weeks? Raise your hand. Okay. Got like 6 people. Okay, 5. Some hands went down. Okay. Do you really feel that way? You do? You're raising your hand? Okay. So let me ask you 5 questions. I'd wait till we get to the next chapter. You think this is tough? Whoa. Let me ask you 5 questions, and this will determine whether or not you'll struggle on tomorrow's test. Okay?
Tomorrow? Not tomorrow, sir.
Well, tomorrow's, yours is Thursday, so
Great.
the other 2 sections are tomorrow. All right. Ask yourself this. Can you name 3 or 4 scientists who developed the atomic theory as discussed in chapter 4? Yeah, last names are fine. We don't care about first names. So, Boyle wasn't one of them. So, give me a name. Yes. Dalton. And what did Dalton come up with? What's it called?
The atomic theory.
The atomic theory, exactly. Give me another one, Will. Rutherford. And what did Rutherford come up with?
He changed Thomson's theory by shooting out particles from the foil and seeing that they bounce off everywhere. So he determined that the electrons aren't part of the big thing.
So there was a discrete nucleus, and most of the volume of the atom was empty space, essentially, in one sense or less. Neve is answering a question. I like that. Excellent. I like that. I'm not being sarcastic. Am I being sarcastic? I'm not being sarcastic. I'm being friendly. Isn't that a friendly thing to say?
You should just answer and maybe you don't listen.
And I wasn't listening because I was too busy speaking. My apologies. I didn't hear what you said.
Democritus!
Democritus. And what did Democritus do?
Me again.
Yes, you again.
He reasoned atoms to be indivisible and indestructible.
I don't think you've ever used the word reasoned in a sentence like that ever in your life. That was very well done, Neve. Very well done. That's correct. That's correct. He was a Greek who reasoned that the atom was indivisible. Right? Indivisible. A hard rock kind of thing. Yeah, and that was really the start of it, wasn't it? But we find that that's not entirely correct, is it? It is correct to... How is that correct? If you added like a clause or like a few words onto that, Will, how would you say that that would be correct? Yes?
It's indivisible without using its identity.
Who is this kid? Is he a student, or is he like works for Attic or something, and he's assessing the quality of chemistry instruction? Well done. Yes. Democritus's theory would be correct if it was extended to say, without losing the identity of the particle, i.e., as an element. Yes.
One more. Robert A.
Millikan. What did Millikan do? What did Millikan do? He measured something. Yes. What did he do?
Like the electron charge.
Exactly. He measured the charge of the electron. Excellent. Okay. Let's continue. That was well done, by the way. What's an isotope? Define the word isotope for me. Yes. Anybody? Yes.
It's basically like a modification of an atom. So
It's a modification of an atom.
yes, it has like the same number of protons, but it differs in the number of neutrons.
It's the same number of protons but different number of neutrons. So let's rephrase that. Can we say it's a modification on an element without changing the
That's all.
nature of the particle? In other words, same number of protons, different number of neutrons. So it's simply a heavier or a lighter form of the same element. Cool?
Yeah.
All right, now, Does anybody know the 3 types of hydrogen that there are, other than hydrogen 1, 2, and 3? Anybody? What's hydrogen 1 called? Remember I put that on the board? I may have said it once, I know. Terrible for me not to repeat myself. Yes? Hydrogen 1, that's a very fair way of saying it. Hydrogen 1, hydrogen 2, hydrogen 3. It's hyphen, it's the name of the element, hyphen, mass number, right? But what is the old classical name for it? Yes? Protium. Protium, deuterium, and tritium. Excellent.
Isn't the third one really
The third one is called tritium, and that's artificial. It's man-made.
isn't it like really
Rare.
less and
It's what?
it's like it's not smaller, it's like
Its abundance is very, 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 very negligible.
yeah, that's what I was saying.
Yeah.
Thank you.
Yes, that's not a problem. I speak students.
Thank you.
Yeah, it's really, speaking student is really quite a language unto itself. Okay, let's do another one. Which of the following is not a part of Dalton's atomic theory? So having that in your notes might be a good thing, to have it written down, the Dalton's theories. You know, like what are the postulates of his theory? Let's see. What's the charge of the nucleus? Essentially, always, without exception, yes. It's positive. So in other words, if you write this, that's the elemental symbol, and this is going to be, let's do one. Lithium, and this is going to be 7/3. What is that 3? What is this understood to be?
Subscript.
It's a subscript, yes.
It's the atomic number.
It's the atomic number, but what else?
Protons.
Yes, the number of protons, but what is it understood to be? In other words, I'll give you one. What's that? Why is that 0? Yeah, that's the charge. It's really, if you want to be very technical, that's really the size of the charge. That's the nuclear charge. It's not the number of protons. It is by default, of course, yes, absolutely. But it's more importantly the nuclear charge. You get it? Otherwise you'd have 1 there, right? Right? Means that particle is neutral. That has a mass of 1. Yes, Will.
I have a question about if you took a particle, well, what happens, because I know that the protons determine what the element is, so if you put all the protons, you set a bunch of neutrons, you put electrons, and everything, what happens?
All right,
What would happen if you took all the protons?
well, excuse me, but you're disturbing him, and he may be trying to listen. So you can see me after class, and we'll talk about that. Yes.
What happens if you take all the protons out of the element and just leave the neutrons and electrons?
The electrons would have nothing to orbit because there's a connection between the protons and electrons. So there's nothing to orbit, so the electrons would just not even be there. It would be nothing because there's nothing to hold the neutrons together. See, the neutrons, I mean, this is really general. It's the answer to your question, but it may not be satisfactory. The question was, what happens if you took away the protons? What would happen to the neutrons in the nucleus and the electrons orbiting? And I'm simply saying that the electrons would just leave, find other places to be, man. Just they'd migrate to something. But the idea of the neutron, the whole concept of the neutron, is that it's glue. It's essentially glue. If you take away the neutrons, let me put it this way. If you take something like uranium, take uranium. Uranium has 92 protons and 100 some odd neutrons, right? So whatever it is, I don't know what it is. Offhand, 238. So what's 238 minus 92? 1 something, right? 100 something, right? Okay. Somebody do that right really quick. 238 minus 92, and then tell me what it is. Okay. So it would the nucleus would collapse. It would just collapse into smaller bits. It would collapse into like different elements, you know, because it would have nothing to it would collapse. It would turn into iron or something smaller, because the neutrons literally act as a glue that holds the nuclear material together. And the more protons you put in there, the less stable it becomes. No matter how many neutrons you put in there, it just becomes unstable.
146.
So 146 neutrons. So that's the limit, really. 92 is really the limit of protons. That's really the heaviest naturally occurring element is uranium-238. You know, matter of fact, if you take away 3 of them, right, you create a more unstable uranium particle called uranium-235, which is the stuff they used, you know, in World War II. Yeah. So that's actually a very good question. Who was the scientist who came up with that idea? No, his name was not It's Time to Go. Sir, no. Anybody? Who came up with the idea of the nucleus? What did I say? Thomson, yeah, Thomson. Or how about the neutron?
Chadwick.
Chadwick was big on the neutron. Very good. All right. So yeah, you've got to know the relationship among the particles: electrons, protons, neutrons, and you're cool. All right. Go to lunch. Get out of here. I'll make another video during lunch if I get at least 3 people up here to make the video, and you'll get extra credit.